Hello, students. Today we're going to be working on graphing quadratic functions. And you'll find that quadratic functions are in the form of f of x equals ax squared plus bx plus c. So that should look familiar to you. Those are the problems that we have been working with on factoring. Now, the most basic of these types of functions would be y equals x squared. And I might note that y equals and f of x equals are interchangeable. F of x is what we call function notation, and then the y is what we use when we're having it as an equation. The graph of any x squared quadratic is a parabola. So the graph that you see to the right is called a parabola. And parabolas can open up, as I've got it shown here, or they can open, it's not pointy, it's a smooth curve. So they can also open down, as I show here, and these should have arrows on them. We have an important point on the parabola, and that is the vertex. And the vertex is either the maximum or the minimum point on the parabola. So in the graph that I have provided, the vertex in this case is a minimum. It's the lowest point on that parabola. The one that I drew in, that vertex would be a maximum. It's the highest point of that parabola. So to graph, we're going to identify the A, B, and C as we've done with factoring. We're going to use a formula to help us find the x value of the vertex. And that formula is x equals negative b over 2a. We're going to make a table of values, and we'll talk more about how to do that. And I am going to let you use a calculator. We're going to find something called an axis of symmetry, and then do some other labeling for our maximum and minimum values. So this first problem is f of x equals x squared plus 2x minus 3. The coefficient of x squared is 1, and so we'll have a equaling 1. The coefficient of the x is a 2, so b equals 2, and the constant negative 3. All right, so the first thing that we will work on is finding the vertex x. We're going to use your formula of x equals negative b over 2a. So we'll substitute in for the b and for the a. So I'm going to use parentheses to hold their places. So b is 2. Notice that it's the negative of whatever we have for b, and then 2 times whatever we have for a. So doing our calculation, we would have negative 2 in the numerator. 2 times 1 gives us 2 in the denominator. And so our vertex x is negative 1. Now notice that this goes in the table for the x in the middle. So negative b over 2a is equal to negative 1. And then I want you to think about if you were counting and you were going backwards from negative 1. So getting to more negative values, that would be negative 2 if we counted backwards, and then negative 3. Or if we counted forward from negative 1, we would be going up to 0 and 1. These are the other x values that I want you to use. So 2 that are smaller than negative 1 and 2 that are larger. than the -1. Just count backwards and then count forward from your vertex. Now, once you have those numbers established, then you may go to Desmos, and we're going to type this in, and Desmos has a table feature that we'll be using to find your other y values. So remember that your equation is f of x equals x to the second plus 2x minus 3. Going to Desmos, I can type in f of x, or I can type in y equals x. Now, if I want the second power, shift and 6 will give me, so that I have an exponent, I can put in the 2, and then I can just down arrow and continue typing. So plus 2x, subtract 3. So now I've got my equation, f of x equals x squared plus 2x minus 3. And then in this graphing area, you'll see a gear. Clicking on that gear will give you some icons, and one of those is a table. And this is what you want to help you out with this problem. So click on the table. Now it will generate some values, but those more than likely are not the values that you want to use. You want your vertex to be the middle number that we found. So we want these to be our x's, -3, -2, -1, 0, and 1. So we're just going to change these. So we said -3, then change this to -2, change this to -1, change this to 0, and the last one to 1. And if you've done this correctly, your vertex will be either a highest or a lowest value for y, and then you'll see repeaters. So on either side of the vertex, you'll see the pattern, the same numbers repeating. And so those numbers we want to remember and write down on our table, on our notes. So we have 0, -3, and 4, and then it repeats -3 and 0. So going back to your papers, we have 0, -3, -4, then -3, and then 0. So those were the values from the table. And now we're going to use these as ordered pairs to graph. So I'm going to graph it in a color I think you'll be able to see. So -3, 0. Remember that your x is -3. Your y being a 0 is going to be a point on the x-axis. So -3, 0. Then x is -2, y is -3. So here's -2, and then down to -3. We'll put a point there. The vertex is -1. So x is -1, y is -4. There's the vertex. And then going back up, we have 0, -3. Notice that it'll be right across from the other point that was at -3. And then your last one at 1, 0. And again, right across from the other point where the y was a 0. And then you will connect these points. It's a little hard to do that with this pen. I'm going to do the best that I can, which is what I want you to do. Make a smooth curve and then connect your points. Put arrows on each end of the parabola, and that is what your graph will look like. It should have 5 points that you are connecting, and it should make a smooth curve at the vertex. So now let's answer some questions. First of all, the vertex as an ordered pair would be for the x in this one, -1, and for the y, -4. So -1, -4, need to write it as an ordered pair. Remember, that is this point right here. So this is your vertex. And again, it is that ordered pair, -1, -4. Now, that vertex is an important point because we have this axis of symmetry that is like a folding line. Symmetry means that the two sides are able to be matched up if we were to fold them. So it goes through the vertex, and we usually will draw that as a dashed line. So I'm drawing a dashed vertical line through the vertex. If I were to fold the parabola on that line, then the two sides would match up to each other. And so this is called the axis of symmetry. And it is a vertical line. And so therefore, it has an equation of x equals a number. Vertical lines are x equals a number. Well, that number is the x out of your vertex. So x equals -1. Notice that it goes through -1. All these x values are -1, -1, 0, -1, 1, -1, 2, -1, 3. All the x's are -1. So its equation, x equals -1. And then the last important thing that we're going to label here is whether or not we have a maximum or a minimum. Well, this parabola opens, as we would say, up, and so it has a minimum value. We'll circle whether it's a maximum or a minimum, and that minimum value is the y value out of your vertex. So the minimum value equals -4. So this being the lowest, it has a minimum. Spell that correctly. It is a minimum, and that minimum is -4. That is not an equation. You'll just have the y value of the vertex. So I mentioned that this graph opens up. You can know that ahead of time if your a value is positive. So if this is a positive value, if positive for the a, then the graph will open up. And if the graph opens up, then you'll know that you have a minimum. So those are the important points that we will want you to be graphing and then answering questions about. Let's take a look at a second example. So on your second example, you have f of x equals -2x squared plus 4x plus 1. So the a is -2, the b is 4, the c value is 1. The first thing that we will look to do is to work on the vertex, which uses the formula x equals -b over 2a. So x equals, I'm going to go ahead and set up parentheses for us to substitute in the a and the b. So b goes first, it's -b, so we'll put the 4 here. On the bottom, a is -2. And so doing our calculation, we have -4 divided by, and then in the denominator, that's -4. A negative divided by a negative is positive. So we have positive 1 for the x value of our vertex. And so we're going to count backwards from negative 1. So backwards from 1. Smaller than 1 would be 0, and then negative 1. And then bigger than 1, going forward, would be 2 and 3. So negative 1, 0, 1, 2, 3. Those are going to be the values that we will want to use for the x's of our table. Now we'll go to back to Desmos. We need to retype in. Now you could just type over the one that you have, or you can hit an X and start completely over. So here we have f of x equals, it was negative 2x. Remember that to get the squared, you do shift 6. So negative 2x squared, I'm going to double check, plus 4x plus 1. So notice that my graph is opening down, and that's because I have a negative for the a value. I want to do the gear to get my table, and then there's my table icon, and my x values were negative 1, 0, 1, 2, and 3. So we'll type those in, negative 1, 0, then 1, 2, and 3. And if it gives you any extras, you can either ignore them or get rid of them. You should see the repeating that occurs on the before and after of the vertex. So remembering these numbers, negative 5, 1, 3, 1, and negative 5. This is what we'll write down in our table. So going to that, we'll have again negative 5. I'll use then 1 and 3, 1 and negative 5. And you can always go back and double check that. Then after you have your table completed, it's time to graph. So you can start with negative 1. X is negative 1. Y is negative 5. Put a point here. Then 0, 1. So 0 is on the y-axis, and then go up to 1. 1, 3. And that's your vertex. So 1, 3. 2, 1. So x is 2, y is 1. Now you should start seeing the symmetry. And 3, negative 5. And again, you should see the symmetry of the points. After you have your points plotted, then you want to connect them in a smooth curve. And if you mess up, erase it and try again. Want to connect all the points. You want to go through, go past the point. And if it looks like you're going to mess up, then, like I said, just keep trying. I'm going to try one more time. Trying to keep a steady hand. And I'm going to let that be it. So there's the parabola. We have then some questions to answer. First of all, your vertex. which is the ordered pair 1, 3. And you can see that point on the graph right here. So ordered pair 1, 3, that's your vertex. We can draw in, and we do need to do that. We need to draw in the axis of symmetry. So a dashed vertical line through the vertex. Make sure you put arrows on that line. So this is the axis of symmetry. And remember that it has an equation of x equals, and then it's the x out of the vertex. So x equals 1. And then finally, you have the question of whether you have a maximum or a minimum value. Since this A was a negative, the graph opened down. And that's because the A is negative. So the graph opens down, which means you have a maximum. So a maximum value, and that would be the y out of the vertex. So the maximum value is 3. So this graph has a maximum value equaling 3. And I'm writing these on your notes so you'll know what we're looking at. You need to fill these blanks in. You do need to draw in the axis of symmetry, and you could label your vertex. You do not have to write the words maximum value or axis of symmetry. You'll have those in your section down in here. So this is what you'll be asked to do on your homework. You can use Desmos. If you don't have access to Desmos, then you can always substitute these numbers in for the x values. But I do know that for accuracy, it will be easier if you will use your calculator to do that. So you're going to be ready for homework 12. It is a worksheet. Be sure that you check your answers and ask for help as needed.